Hey everybody, this is Larry. This is me with Q2 of the bi-weekly contest 163, number of perfect pairs. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, this is, I don't know. I don't know how other people did it. This video, I'm going to only show you how I did it, right? Not gonna lie. Maybe there's some elegant, crazy proof, and I don't doubt that there is. Because some top people did it very quickly. Top non-cheating people, I just want to add. Did very quickly. If you're good at math, maybe this is a regular pattern that people are able to see. For me, honestly, and you could see from the timing and maybe the length of this video, I took 23 minutes or so, more, a little bit less, 22 minutes. And about 20 of those minutes, I have no idea what I was doing. But as soon as I figured it out, it was an easy thing to code. And honestly, yeah. The way that I kind of played around, you could kind of watch the live portion and maybe on like 5x or something fast. I tried to kind of break it down into different scenarios and try to figure it out. Honestly, it took me a while and I was like, that doesn't even make sense. And the way that I honestly finally did it is just by writing the brute force code, not on the nums, but on another dimension, on A and B. And just try to figure out if I could figure out the pattern. And I did. That's basically the idea. One is that apparently it doesn't, well, the way that I structured it, it didn't matter the absolute value, right? Yeah, and that's basically why I had this. And honestly, I don't have a great answer as to how, I know there's stuff that you could, because this is maybe 2 times one of the numbers or something. There's stuff that you could justify, but honestly, for me anyway, I don't have a great proof about it. Oh, what the? Okay, fine. But yeah, the thing that is that I just ran these for different numbers, and I go, okay, well, 15, it goes to -30, right? And also on the other side, it goes to, well, divided by 2, round up. And that's basically, I tried it with different numbers and kind of came up with this pattern, and that was honestly how I did it. I don't think there's any, if you watch the live portion, you'll see, which is that for every number x, it goes from, for every number x, it goes from x divided by 2 to 2 times x, right? One of them being that it is the smaller number, the other being that it is the bigger number, of course. And I assume, honestly, like I said, I'm a little bit hand wavy because I don't know, right? I assume that this is just this part of the property and one of these and that. And I think maybe it's something that's well known. Let me know in the comments. I don't know it, so I wouldn't say this is well known for me. But like I said, maybe it is well known. Who knows? But that's how I did it. I just kind of figured out the pattern. And then once you have to figure the pattern, like I said, it's going to be divided by 2 and 2 times. So we just do a bisect left, bisect right to kind of count the number of inclusions. And then we just count that, we add that. And yeah, and I did it only in a way such, for this technically, the way that I structured it, you don't need to sort it. I did anyway. But as a result, then you can just do it this way. Yeah, and this is just a binary search. I'm not going to go over it in this problem, but yeah, it is just that you have an array. All the numbers, actually, I guess you have to, if you don't do it this way, that if you don't sort them, you have to use a sorted list because then the numbers can get out of order. But of course, you have to maintain P in sorted order. And because we do this in sorted order, this is already sorted. So then, yeah, so then we could do a bisect left, bisect right to get the left side and the right side. That's not what bisect left and bisect right means, by the way. Maybe I said that in an awkward way, but yeah, but to get the half inclusive, and this is round up, and this exclusive, so then now left and right will contain the numbers between here and here inclusively, and then we just keep track of the count, put this in the future, or put this now in the new past so that future numbers can process it, and then just sum up all the count. You can see pretty straightforward once you do this. And again, I had this and commented, but just want to show you. And that's it. This is going to be n log n from this sorting, but also for each n, you have binary search anyway. So n log n, a few times. But yeah, that's it. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, you could watch me try to struggle through it a long time with different variations of me trying to solve it in different ways. But as soon as I had the for loops, it was like, and yeah, just to be clear, like when I wrote these loops, I don't know what I expected to see. I was just hoping to like try to figure out pattern, and the pattern was actually kind of obvious in a way. If you really want to, you could see that in the live portion. And then once I figured it out, this part is pretty straightforward. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live in the contest now. Right? So anyway, okay, Q2. Nums ij is perfectly following conditions are satisfied. Okay, integer array nums, and looking at constraints and there any all range of numbers. Okay, I and j are perfect if. Oh jeez, what does this even mean? I guess this is one of those, and we have to try to figure out what. Okay, I don't know what that means, right? So maybe we could draw it out. The way that I like to think about these is that we play around with some small numbers, but also let's look at the example, because yeah, okay. Because the example will play around a little bit. So 1, 2, ij is 1. It is a little bit confusing, but okay. So min. What does this mean? So min of either the delta or the sum. That's interesting. I don't know what that means, but. And then you have the max of those two. So it's between the. No, what? Oh. So the smaller numbers, I don't know. This is a very difficult to read point. I mean, maybe it's the solution may be like 5 lines of code or something, but it's just, for me, a little bit confusing. Okay. I mean, okay, so I mean, the general idea, I still don't know how to solve this, but given that this is 10 to the 5th n, basically we want to process one number at a time and then maybe do a loop for all these things, and it's just case analysis at that point, right? So basically, for example, we can break down the min and the max, meaning that, okay, so yeah, so we given x, where x is the number we're processing, then we just look at the numbers in which a is x and then b is x, right? Or maybe that's maybe better thing is that min of ab is equal to x, and then max of ab is equal to x. So we kind of divide them into two scenarios, right? So basically, this is saying that the past number is bigger or equal. I won't say or equal to, but we have to worry about dedupes with the max as well, right? This is a really, because you're basically trying to separate it out so that you could process all this in one go, right? This is just too much thinking. Okay, for Q2 I mean, but okay, the past number is bigger or equal to. Okay, well, so what does that mean? That means that x is. That's just yeah. Okay, I don't know. That means that b is bigger, or let's just say p is bigger than x, the previous number, right? Maybe that's a little bit better. Okay, so then p minus x, because it's going to be greater than 0, right? Is that true? Yeah. Because by definition, we said it's going to be bigger. P plus b, can it be? The thing is, both these numbers can be negative, so it can be really small. So you can't just say that this is going to be bigger than the other, or the previous number, they both may be positive. They're both positive, then it's going to be really big. So you can't really generalize the min and the min-max relationship, huh? I mean, we could do case analysis, but there's like 8 cases or something. I don't know, or maybe just 4, 8. I don't know. It's just way maybe there's only 4 cases. This is always true, and then it's just either this is always true. Yeah, okay. Because I'm trying to figure out this part, right? So we don't have. So then it becomes you know, without the absolute value. And then a plus b just could be anything. But we can, okay, so that part, we're searching for numbers. This is just annoying as, unless I'm like overthinking some easier trick. Okay, actually one thing that we should do is sort. I forgot. Okay, let's just say we sort them because ij doesn't matter. Then now, okay, then now we only look at previous numbers which are all smaller. Yes, that's a little bit better. Okay, so then now all the previous numbers are smaller. So that means that we don't have this scenario, okay? Right, so that means that p is, the previous number is less than or equal to the current number. Maybe that's a little bit, so we don't have to worry about this. That means that here, this is going to be the previous number always, because that's going to be min, and the max number is x, right? The current number we're processing. And then this is the previous number. So it, I mean, this still is fine, but this just becomes x minus p because it is the smaller number, and then the sum of these, right? So then now we can do case analysis, maybe? Man, I am spending a lot of time on a Q2. I don't know if it's just me, but I mean it's binary search, but I'm trying to figure out the exact binary search, right? Like I don't have any trouble with what I need to do, but it's just the math part. Okay, so this number is always positive, right? This is the current number, this is the previous number. I don't know how to separate these. I mean, the idea is that you, that you cache not the p, but some function of this. You probably have to cache two functions in which well, let's just write x plus p, but it's a little bit nuanced, right? Because then now the min function is just a weird function, right? But let's just say we add plus p on everything, right? So that's plus p, this plus p, and then this plus p, but it's outside of the thing, maybe, right? Because this is absolute value. Can I absolute value the components? I guess not, because this could be, one of them could be negative, then you don't absolute the value. How do you, I mean, okay, so there are really only two scenarios, which is, and maybe we should go for it. X plus p is greater than equal to 0, then it's just min of x plus p, right? And then this, of course, is just equal to two scenarios, which is whether p is greater than 0 or not, right? If p is greater than 0, then you have x plus p, because if it is greater than 0, no, okay, I'm wrong. If it's greater than 0, then min is x, so you have x to the p plus p, right? But if p is less than 0, then this chunk is smaller, so you have x minus p less than, you go to p plus p, and then you add the p plus p on both sides. So then now you have x is less than 4 times p. I don't know, right? So we have to process every numbers like this, and then we could do it this way, maybe, right? We also have to kind of do this math, right? This is such an annoying problem. How do people? So many people got it because I cheated and looked at the user accepted. It's a good amount. A lot of people got them very fast. I don't know how. Oh well, unless it's cheating. I don't know. Maybe I'm missing something obvious though. I mean, it's very possible. Okay, case analysis. Let's go. Okay, so you have this, right? X is greater than, or you go to P. Okay. Wait, is that the case? Or oh no, this is always the case because we sorted. Yeah. Okay. Okay, so then now we have x plus p is greater than 0, or you go to 0, then that means that we have max of x plus p plus p plus p. Well, if we have this function, if p is... Did I mess up a thing? No, I did mess up a thing, didn't I? Well, I missed a case in which we have to figure out what x is, and if x plus p is less than 0. All right, let's go through this first. If it's less than 0, then what happens? I don't know. This can't be right? I feel like I'm like, this is a ridiculous solution to do. I mean, you could do it, but I feel like I'm missing something. The sorting doesn't really, I mean, it does simplify for sure, but then you have all this craziness. Alright, let's take a look at the examples real quick. You have -3 and 2, min... Oh, I missed this. It's min of the absolute value, not... Oh, snap. That's different. I missed that. How did I miss it? Okay. I mean, I don't know if it's right, but it's different. Or I don't know if it changes anything. Oh, man, now do we do this? Oh, that's annoying, actually. Okay, well, we still... let's see. Maybe that makes it easier. So, you know... and we use our notation of x minus p. We know that this is already x is greater than or equal to p. This is xp, right? So that means that... and this depends on whether... that's annoying too, right? Like it's not a binary search the way that I want to do it, but and I always spend like more than 10 minutes just struggling on this one. Like, I mean, I could case analysis it, but it's just so many case analysis. I'm struggling to believe that that's what everyone did, you know? I mean, and did it so quickly. Let's see. Okay, so x is minus p, we know that is true. There's something weird about this relationship that I don't know. X plus p, what does that mean? How do you search for it in a good way? Yes, that's what I want to know. And then the max and the min. Like, maybe a lot of it is just not possible, but I don't know how to figure it out. I'm gonna come back. I feel like I'm spending a lot of time on this. Dope. And people, I mean, I can't stop looking at the leaderboard. It's just silly. But I don't want to go forward yet because it's just like I take a quick peek and few people solve the other two. But how am I stuck on Q2? Like, you know. Do we just process things in a weird way? Okay, so let's say x is the min, but then you have to take care of the max, which is the other number. So it's like some sort of case in, I don't know. What am I doing? And again, maybe you could do some. I need to draw. I think I need to see this more visually. That's how. Okay, I'm just going to draw in a notebook. Maybe I can't do it in a, mathematically or whatever, but I need to draw it out. Okay, so let's say we sort that. We have -3, -1, 2, 4. In fact, whatever, right? Maybe we do, maybe we don't. But we need to. What I can do instead of drawing it out. What is a perfect pair, right? So maybe it's like a. If I draw it on a 2D plane, what would it look like? I think that's the thing I want to know, right? Okay. I was going to write a brute force version, but I actually want to do something a little bit different. I'm going to put this in a paste pad somewhere so I don't lose it real quick. Okay, so then now I want to do like something like something like this, right? So if if min of like, I just want visualization. I think that's what I'm trying to do. Okay. Okay. I guess you could just return this. I have to change some code. I mean, I obviously copy and paste, and then match up this. Okay. Right. Oops. I guess this is actually too big. Maybe it prints too many things. Oh, that's not right. Did I mess this up? That's definitely not right. What am I messing up? Min of a minus b, a plus b. I can't even do. Oh, whoops. Though maybe 1,000 is too big to start off with. Let's just. Okay. It's okay. One number is 100, -100. It goes to -50. Right? I guess that's how. I mean, they just kind of. Okay, -100 goes from 100 all the way to -50, and then 50 all the way to 100, or I assume, or to 99 maybe. Oh no, it's just that we don't. Larry, Larry with the dubious patterns. Okay, fine. Right. Maybe this is. Maybe I should have done this a long time ago. Okay. I mean, it looks like it's just the one number has to be half the other number. I guess that's the short thing. We sort them, right? So it's gonna be maybe we sort by the absolute value. Does that help? The a plus b part is still confusing to me though, so I don't know if that's quite right, because I mean, I know that this goes to -50. Okay, 98 goes to 49, and 100 is. How big does it go to? I guess it should go to up to twice as much because of the other side, right? So okay, I guess that's not so bad. Once you see the pattern, it's not so bad, I think, to implement. Let's say 65, we have 33, and does it go? Well, it only goes to 100 because that's what we have. So all right, let's try. Let's try one of the numbers be smaller, and then we can see. And it should only go up to 60 from the other side, reciprocal or whatever you want to say. right? So yeah, negative 60, even though it goes up to 100, so it goes outside of range. Okay, so I mean, this is pretty straightforward to implement now that we see the pattern. And yeah, apparently the pattern you can't really figure out analytically. I couldn't figure it out analytically. So yeah, so then now, is it true that the numbers don't matter, or is it just absolute value? Right? Wait, let me. Meaning that we could process this by the absolute value, right? And you could do like a sort sliding window thing, but or 2 pointers, not sliding window specifically, but yeah, I think like you get absolute value for each one, right? So maybe yeah, so nums x for x and nums, right? So something like this. Let's just put it in comments in case I need it. I mean, I guess it's pretty straightforward. But for x in nums, p is equal to yeah, okay. No, I was going to write it differently, but okay. So then p dot append x, and then we just binary search left is equal to so it goes up down to half. Wait, I guess that's why we kept it here. I know that it goes down to half, but I forget if it rounds up or round down. Like, okay, let's say we have 29, we go up to so it rounds up. Okay, I actually also want to confirm this on the other side because we've been doing it on the negative numbers. Let's just say 10. So yeah, well, 10 will be round up. So 11 rounds down to 6. Okay, so we okay, yeah, okay, fine. I mean, I took a long time on this, but apparently people could either do the math better than I can or something. But yeah, then now we have p dot bisect left x round up, right? We have, let's search for p. We want this lower bound, right? Yeah, and then right is equal to bisect right p 2 times x. Yeah, and we want to be inclusive, so it's bisect right, and then it is just count to do right minus left. It doesn't include the right, so it should be okay. Yeah, okay, something like that, right? We have 240. All right, let's go. Okay, that was a tough one for me anyway. I don't know how other people did it. I had to. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see you all later and take care. Bye bye.